Hey everyone, today I am going to show you this really cool lightweighting strategy, and this is a very common strategy, but I'm going to modify it today to specifically make it relevant to resin printing. So SLA printing, DLP printing, stereolithography, vat photopolymerization, whatever you want to call it. You could see here, you'd have a lot of resin trapped inside there if you just did it this way. So I'm going to show you how to implicitly design some drain holes and put them in creative locations that will help drain without ruining the aesthetic of the part. So we've got high strength, lightweight, and drainable parts for photopolymer 3D printing. That's what we're going to do in the end. So let me start from the beginning. So what I have done here is I am modifying one of the simple examples that is provided by N-Topology. This is something that N-Topology users will recognize from the current loading menu. So it's a workflow. We're going to shell the part and infill it with a lattice. I'm not going to go in super detail through everything that's part of the normal workflow, but more focus on where I've made these modifications. So just quickly to orient everybody, so we've got the part, the normal workflow, we'll make a shell out of that. We will then create this lattice, and then we're going to use that in a second. Then in the normal workflow, it end here. So basically, we're shelling, we're creating this volume lattice, and then we're merging the two things back together. But this is where, when my team's been using this workflow for our customers, if we just stop here, what we end up doing that's kind of annoying, and this was really the motivation for making this video, is, well, now how am I going to get the resin out of this part? And so what we were doing is, manually punching little drain holes in this thing, and it just it wasn't particularly efficient nor fun, nor does it always lead to beautiful functional parts. So I wanted to get a little bit creative with this workflow, and so what I've done is I've actually taken this original lattice that we've used. So here's all the input parameters. I'm not going to walk through all the default ones in detail, but I've taken the original lattice that we're using to reinforce it, and then I've actually offset that by a vector to create this second lattice that I'm now going to use for drain holes. So why did I do it this way? So this is going to guarantee that so the blue lattice is being added to the shell to reinforce the part. The red lattice is actually being subtracted from the shell. And I really want, if those were overlapping, then it wouldn't be very reinforcing. So I would actually be undermining the very reinforcement that I'm trying to build. So what I've done here is I've offset these lattices such that they are not in each other's way, right? So they're interlocking. In this case, you can play with that offset vector yourself, and you'll need to do a little bit of work in terms of thinking about the right offset vector for the lattice type that you're using. But for this FCC lattice that we're using, having an offset vector that is half of the lattice scale vector in each direction gives you this perfect interlocking mode. Okay, so now you can see, so if we just are now draining the lattice based on that red, I'm going to now isolate this view. You could, oops. Here we go. Drain to drag everywhere. So if we are just, oh, that's what I did wrong. So Let me fix this quickly, which is, and now you can see how I made it. If I'm just, so this will be fixed in the version that's uploaded. If I just drain everywhere, then part looks kind of crazy. So this is cool. Maybe you'd like this. Could be really interesting, especially on the base, as like a nice way to keep, you know, good adhesion, but good drainage, not get any suction. You know, sometimes in resin printing, you can get this kind of water cup, upside down water cup under water effect of a suction cup. So this is cool and would work, but now we've got all these holes everywhere that might not be what we're going for, either aesthetically or functionally. You know, this external surface having all these perforations in it. So instead, what I built as a workflow to make this a little bit easier is the ability to define some other implicit body that's going to cap the volume in which we are doing the subtraction. So I'm calling this the drainage volume is this implicit that I'm dragging things into, and it's really just a placeholder for whatever shape that I want. So what I did is I said I actually just want the draining to happen inside this cylinder that you can see highlighted in blue. So this lattice, it only at the intersection of this subtraction lattice and my drainage volume am I getting the drain effect. So now you can see that's happening on the inside of this bigger cylinder and would be nicely out of the way. I could easily have put two more cylinders here, union them all together, and gotten a nice, you know, drainage on each of these. But just my intuition about this part and printing a lot of parts is this would actually print pretty nicely and drain very well. Also, you might notice I did add to the workflow, because I think it's super slick and it makes really nice strong parts, blending radius between the reinforcement lattice and the shell. So that's something that I've added here for you. So you can see, yeah, now in the end, we've got the final implicit. We've selectively created this drain area volume, and then we've kind of implicitly set a drain subtraction lattice that we know is not in the way of the reinforcement lattice, so that we have all of the lightweighting and high strength reinforcement that we wanted, while making this functionally printable for resin printing. So then at the end, I got a little tip here in terms of meshing these things. I've created this nice rule of thumb where we're going to just mesh it at a quarter, where the tolerance is a quarter of that beam diameter. And then this mesh STL upload, you will obviously want to print out of the most rugged materials available to you, which we would be happy to do for you if you want to upload your final mesh to parts.polyspectra.com. I'm not going to make you watch me decimate this mesh, but if you want to spend a little bit more time in NTOP and a little bit less time uploading files on the internet, you can check this simplify button. So again, just a quick recap. We have extended this shell and infill example to create implicitly designed and confined drain holes to make it relevant to resin printing, then shown how to mesh that, have the opportunity to upload that to a very high performance parts printing service, if I do say so myself. And I'm going to make sure to include the link to this notebook, which I'm going to hit save on now, in the comments below in the notes for this video. Would love to hear your feedback on this. Do you have a better workflow? Do you have a different workflow? Is there something that we didn't explain that could be better? Love to hear from you, and hit subscribe for more content just like this.